Have you ever felt like you totally know the material, but your exam scores just don't reflect it? Well, today, we're not just going to solve math problems. We're going to decode the exam itself. We're going to pull back the curtain on the hidden patterns examiners use, showing you exactly how to lock in every single mark. Let's dive in.
So just stop and think about it for a second. When you get that exam paper in your hands, what are you actually looking at? Is it really just a random list of questions that are designed to trick you? Or is it something else entirely? Think of it like a blueprint, a code. And once you learn how to read that code, it tells you exactly where all the marks are hidden and how you can get them. And that's what we're doing here today. We're decoding that blueprint. To kick things off, we need to get inside the head of the person marking your paper. We're going to break down a few key questions from this paper to see what the examiner is really looking for. All right, first up, a total classic. Find the LCM. Now, this seems simple enough, but you know what? It's actually designed to test a very specific skill, how well you understand prime factorization. And here's the secret sauce. The marks aren't just for that final number you write down. Nope. You get credit for every logical step along the way. Did you show the right prime factors? Boom, that's a mark. Did you select the highest powers correctly? That's another one. See? The final answer is just the last piece of a bigger puzzle. And this is the common trap that gets so many people. Just multiplying the numbers together is not, I repeat, not finding the least common multiple. It's a surefire way to lose marks because it tells the examiner you've missed the whole point of the question. So here it is, the method that gets you full marks every time. Step 1, you factorize. Step 2, you select the highest power of each prime you found. And step 3, you calculate. Now here's the best part. Even if you make a silly mistake on the final multiplication, just showing those first two steps proves you know what you're doing, and that alone can get you partial credit. That's a huge deal. Okay, let's switch gears and look at a different kind of challenge. One that's more about logic than straight-up calculation. These assertion-reason questions, they're all about understanding the why behind the math. You know, the best way to handle these is to just break them down. Treat them like two separate true or false statements. First, just look at the assertion. Is it true? Are these lines actually coincident? Meaning, are they literally the same line? Then, you look at the reason. Is that rule they gave you a real valid mathematical rule? And here's how we test it. Let's check the ratios of the coefficients. Okay, 3 over 1, that's 3. 6 over 2, that's also 3. And 3900 over 1300, yep, that's 3 too. Since all the ratios are equal, they perfectly match the rule. So the assertion is true, the reason is true, and the reason perfectly explains the assertion. That's how you get full marks. Now, let's look at something else. Sometimes the marks aren't in the numbers at all. They're in the picture you draw. An angle of elevation question is a perfect example of this. Okay, seriously, before your pencil even hits the paper, the single most important thing you can do is stop and just visualize it. Picture the person looking up, picture the building, picture the ground. Get that mental image crystal clear in your head first. Why? Because this is basically the examiner's secret checklist. Is it a right-angled triangle? Check. Is that 60-degree angle down at the bottom where the observer is? Check. Is the base labeled correctly? Check. If you miss even one of these details, you could lose all the marks for that diagram. All right, now that we've done a deep dive into the logic, let's speed things up a bit and see how this pattern applies to other questions. It's all about quickly recognizing what's being asked. This looks super simple, right? Find the volume of a cube. But even on the easiest questions, there's a pattern to follow, a specific way to show your work that guarantees you're not leaving any marks on the table. So, what's the first step? Always, always, always state the tool you're using. Just writing down the formula, v equals a cubed, is like telling the examiner, hey, I know exactly how to solve this. It's such a quick and easy mark to get. And then you have the final answer. But notice, it's not just 64, it's 64 cubic centimeters. Those units are part of the answer, and forgetting them is such a common and careless way to lose a point. Let's do one more real quick, a probability question. And you guessed it, the logic is simple, but how you present it is everything. The absolute key to this question is showing the examiner you know the fundamental concept here, the complement rule. Writing this little formula down, it's pretty much non-negotiable if you want that mark. And from that point on, it's just simple arithmetic, right? 1 minus 0.05 gives you 0.95. It's the same pattern all over again. Formula, substitution, answer. See how it works? Okay, so let's wrap all of this up into a final master strategy.
Think of it like a simple algorithm that you can apply to pretty much any question to max out your score. So here are the rules of the game. You always show at least one logical step or formula. You always box your final answer to make it super clear, and you always use the correct keywords. On the other hand, you never jump straight to the answer. You never skip your reasoning, and please never hand in a messy, unlabeled diagram. And really, that's the ultimate takeaway here. An exam isn't just a test of what you know, it's a test of how well you can communicate what you know. It's a game, and it has clear rules. Once you learn to see the patterns and start speaking the examiner's language, the marks, they'll just follow you. So stop just answering questions and start playing the game.